So if you remember last class, we just saw what are all the different types of processes. So the overview of the process and its conditions. You can see here for adiabatic process, the condition is Q is equals to 0. For isothermal, dt is 0. Isobaric, dp is 0. Isochoric, dv is 0. And cyclic, internal energy, delta dH, dp, dv, dt all are 0. Next we saw functions. Two types of functions, state functions and path functions. So state function, what is a state function? A thermodynamic system can be defined by using the variables like pressure, volume, temperature and number of moles, right? So a thermodynamic system can be defined with the help of these four variables. A state function is a thermodynamic property of a system which has specific values for a given state and does not depend on the path or manner by which the particular state is reached. So, for example, what are pressure, volume, temperature, internal energy, enthalpy, free energy? All these parameters, they depend on the initial state and the final states. So start of the reaction la what is the pressure? End of the reaction la what is the pressure? Starting in a temperature, ending in a temperature. They depend on the initial and the final state, whereas they don't depend on the path or the manner in which the reaction has proceeded. So then what is a path function? A path function is a thermodynamic property of the system whose value depends on the path by which the system changes from its initial to final state. A path function is not bothered. Start ஆகும்போது what is the temperature or end ஆகும்போது what is the temperature என்றது it doesn't bother. All it bothers is the path in which it has traveled. For example, work, heat. Okay, these are all examples for path functions. Work W will have different values if the process is carried out reversibly or irreversibly. ஒரு ரியாக்ஷனுக்கு ஸ்டார்டிங் அண்ட் இனிஷியல் அண்ட் எண்டிங் பாயிண்ட் இருக்கும். Okay, Anna அதே வந்து if the reaction is reversible and irreversible, I told you all irreversible process are natural process and spontaneous process. அப்போ அதோட reaction is definitely different from an irreversible reversible. What do you mean by reversible? The original state can be, or the initial state can be reached from the final state. அப்போ அந்த path தான் நம்ம பார்க்கணும். So work and heat will depend on the path of the reaction. Okay, so they are path functions. And pressure, volume, temperature, enthalpy, entropy, free energy, internal energy, these are all examples for, you can see, state functions. Next, internal energy. Now what is this internal energy? The internal energy is a characteristic property of a system which is denoted by the symbol U. Sometimes they will denote it as capital U, sometimes they will denote it as capital E, but both means the same. The internal energy of a system is equal to the energy possessed by all its constituents, namely atoms, ions and molecules. So what do you mean? ஒரு reaction நம்ம எடுத்துக்கிட்டோம் அப்படின்னா அந்த reactionல how many atoms are there, how many molecules are there. So the energy possessed by all of them, whether it is an atom, it is an ion or it is a molecule, that is called as internal energy. So the total energy of all molecules in a system is equal to the sum of their, see, translational energy, another total energy. Total energy of all molecules is the sum of the translational energy, vibrational energy, rotational energy, bond energy, electronic energy and energy due to molecular interactions. So thus U, that is the total internal energy, is equals to translational vibrational, rotational, bond energy, electronic energy, and molecular interactions. Then the total energy of all the molecules of the system is called internal energy. In thermodynamics, one is concerned only with the change in internal energy. So any change we write it as del. Change in internal energy na delta U rather than the absolute values of energy. So now we will see what is the importance of this internal energy. The internal energy possessed by a substance differentiates its physical structure. Other first, for example, carbon, allotropes of carbon we know. Graphite is an allotrope of carbon, diamond. Okay, each of them, coal, right? They differ from each other because they possess different internal energies and have different structures. So the first importance is internal energy differentiates its physical structure. Characteristics of internal energy. இந்த வாட்டி இதை கேட்டிருந்தாங்க. This time they asked this for 5 marks in public. Internal energy is an extensive property. Do you remember we studied about extensive property? That is, it depends on the amount of substance present in the system. If the amount is double, the internal energy is also doubled. Second, internal energy of a system is a state function. It depends upon the state variables like pressure, volume, temperature, number of moles of the system. Then change in the internal energy, see, delta U. How can you express delta U? UF minus UI. U final internal energy minus initial internal energy. Okay, this is the third point. Fourth point, in a cyclic process, there is no internal energies change. அப்போ delta U is equals to 0. எங்க delta U cyclic. நீங்கள் இதெல்லாம் எழுதுனீங்கனாலே கூட உங்களுக்கு மார்க் தான். If the internal energy of the system in the final state is less than the internal energy of the system in its initial state, அப்படின்னா delta U would be negative. அதாவது என்னது? Delta U is equals to, what is the formula? Delta U is equals to UF minus UI தான் formula. If it is negative, எப்போ அது நெகட்டிவாக இருக்கணும்? ஃபைனல் ஸ்டேட் வந்து லெஸ்ஸாக இருக்கணும். When the final internal energy is less than the initial internal energy, then delta U is negative. If the internal energy of the system in the final state UF is greater than the internal energy of the system in its initial state, then delta U would be positive. அதாவது UF should be greater than UI. அப்போ delta U is positive.